Hello everyone. In this session, we are going to discuss about the addressing for MicroLogix PLC as well as for SLC final address. Okay. So initially, we are going to start with the modular type PLC, means the SLC 500. So here you can see the PLC is given here, right? So the first block is of the power supply block, which we have already discussed. Here the terminals are given for providing the power supply. Right? This is the 24 volt DC power supply. Okay. So as and when you are thinking about the addressing for such types of PLC, you have to take care of, you have to focus on these essential points. Means you have to know in which slot we have inserted the digital input card, digital output card, analog input cards, right? So similarly, here you can see as per the discussion in last session, we have to insert the CPU in slot number 0. So we have inserted the slot CPU in slot number 0 already. Now here you can see the slot number 1. In slot number 1, we have inserted the one digital input card. Again, in slot number 2, we have inserted one more digital output card. And here in the last number slot, we have inserted the digital output card, right? So here if we are counting the number of digital inputs and digital output, finally you will get to know in slot number 1 and slot number 2 total 16 outputs, 16 inputs are there actually, right? 16 inputs are there, and in slot number 3 total 16 outputs are there. Means in this PLC we have a total here, let me change, total 16 inputs, means the 0 to 8 and 0 to 8, 0 to 7 and 0 to 7, right? Means total 8 and 8, 8 plus 8, 16 inputs are here. Similarly, if you are observing this output card here, total 32 outputs are here. Means this PLC is available with 16 inputs and 32 outputs, right? Okay. Now here you can see here we have connected the lamp, right? So lamp to the 27th number terminal. It means the one terminal of the lamp is connected to the 27th number terminal, and the other terminal of the lamp which we have connected to the common terminal, right? As per the discussion in previous session, right? And we have provided the power supply as we have already discussed. The first terminal of the of our digital output card, that will be plus VDC. Okay, plus VDC means through which we are going to provide the power supply to our digital output, right? So here you can see if you want to provide address to the lamp in the software, so how to provide the address, right? So let us consider that here in slot number 1 we have inserted digital input card, and in slot number 3 we have inserted digital output card, right? So in this session we are just going to focus on digital input and output addresses, right? See, here you can see this is the table. Here you can observe the address also, I colon 1 dot 0 slash 0, right? So what is the meaning of I? I is nothing but the input, or we can see file letter also. This is nothing but the slot number, means in slot number 1, here you can see in slot number 1 we have inserted the digital input card. That's why 1 is coming here, right? Then the next 0 means what? The 0 is nothing but the word number, 0 word. Okay. As we know that in Allen Bradley PLC, we cannot start anything with the 1. That is the reason we have to start it with the 0. Okay, means 0 word. 0 word means what? It contains total 16 bits. How many bits? 16 bits, right? Right, 16 bits like this. Word 0, total 16 bits. 1, 2, up to 16 means in the software you can observe 0 to 50. It's mean that in the 0 word, we have a provision to provide address for 16 different inputs. Okay, 16 different inputs. For example, here you have connected one switch like this to the terminal number 0, and to the terminal number 0 we have to provide the addressing. So what will be the addressing? See, it is very easy. So simply we just need to do one thing. For the input, we have to use I colon. Here we have inserted the digital input card in slot number 1, then the 1 will here I colon 1 dot 0/0, right? In word number 0, the first bit will be there, means the 0 bit. Which one? This one. The 0 number bit is here, right? But in the software, you can observe the 15 will be here and 0 will be here, means your 0 bit number bit will be here, then 1, then 2, 3. Accordingly, we have to provide the address, right? For example, if you have connected one more switch to the 5th number terminal, then your address will be like this: I colon 1.0/5. Bit we can see it in the software, and terminal which we can see it in the field like this 5th number. Okay. Similarly, if you have to extend the number of inputs, okay, or number of outputs, so that is also possible. Okay, means you have used all the available inputs in word 0. Simply you have to focus on word number 1. Okay, means what will be the address for word number 1? Simply instead of 0, here you can observe the 1 like this: I colon. Now here I have just inserted the digital input card, which is having total 16 inputs, right? Means for the 16 input, word 0 is more than sufficient. But if these two cards are with the 16 inputs and 16 inputs, then we have to think about the slot number as well. Means I colon 2.1/0 like this. The slot number will change, word number will change like this. Okay. Now the same way we have to address the outputs also, right? So here what we need to do now, here we are going to provide address for this lab, which is connected to the 27th number terminal. 27th number terminal. The same thing you can observe for the output. O means what? This is the notation for our output. We can see it file later also. O colon 2.0/0. Okay. So here I have mentioned the 2. Okay. But right now here you can see our output card is inserted in slot number 3. So instead of 2, here you can observe the 3. Okay. The slot number will change. Means your address will be like this for the 27th number terminal. O colon 3.0/27. Okay. 27 means this is the address which we need to provide into the software. Means to say, as and when you are thinking about the addressing, you have to focus on the slot number, right? Okay. Now the few more addresses which you can observe into the PLC, like the binary addresses, right? The binary addresses means what? In the industrial term, we can see the dummy addresses also. Means, for example, if you have the PLC which is having the 4 inputs and the 2 outputs, right? And if you require the few more inputs and few more outputs, okay, but we don't have, still you want to design the program and you are just going to show a few inputs and the few output on field, but in order to fulfill the logic of your program, you require the few more addresses. So instead of using the real input output, you can go with the binary addresses or the dummy addresses. Here you can see the B3. B means what? The file letter, and 3 means what? The file number, right? Actually we can see data file number. Okay. So B3 colon 0/0. So for this address, you cannot observe the slot number because this is the software address. This is the software address. Okay. So in the upcoming session and during programming, I will tell you how to use this binary bit in addressing or while designing the program as well. Okay. So similarly, B3 colon 0/0. Then the next address that will be B3 colon 0/1 up to last address B3 colon 0/15 for this word number 0. If you have used all the bits which are available in word 0, then you can switch to the word number 1. Okay. Again in word number 1, you will get the 16 inputs, binary inputs. So in this way, you can use this address, right? So this is the software address actually. Now, let us see the small example, means how you can able to provide this input into the software or while designing the program. It's very simple. See here. For example, here I have connected one toggle switch like this, okay, to the terminal number 0, and as we have already connected the lamp to the terminal number 27, right? So the address for this terminal, that will be I colon 1 dot 0 slash 0. Now we have to design the program. So how to design it? Now simply we have to use normally open contact. So for this we are also going to learn the ladder logic rule, so don't worry about that. Okay, this is just for the example. Now here like this. Okay, so we need to provide the address here. I'm providing the address like this, and this address means O colon 3 dot 0 slash 27. Means when I press this switch, then accordingly you will get the response on your you will get a response from the lamp as well. The same thing you can observe into the program also. So when I press it, then you can observe the green color here, means the power or the current start flowing through this rung, and it will energize the lamp in software also as well as on field also, right? Now let us focus on the addressing for the MicroLogix type PLC. Actually this part is very easy. In this addressing you cannot observe the slot numbers, right? Because no slots are available in the MicroLogix type PLC. See, for the input again the notation that will be I, and for the output the notation that will be O, right? So you just need to skip the slot number. So your address will be like this: I colon 0 slash 0, right? For the output O colon 0 slash 0, right? Means like this: I colon 0 slash 1, I colon 0 slash 50. So this will be the last address, right? Means total here the 16 bit for the one word. Ready? Similarly, you have to repeat the address for the output also: O colon 0 slash 1 like this up to O colon 0 slash 50. Okay, means while providing the addresses to the MicroLogix PLC, we just need to remove the slot number. Okay, then that particular address will become the MicroLogix PLC address, right? And the binary address that will be same for the MicroLogix also. So very soon we are going to start implementing this address into the upcoming session and while designing the program. So this is all about the addressing for the MicroLogix as well as the SLC 500 PLC. Thank you.